As we approach this activity, the most important thing is to show our work through dimensional analysis. Remember, that's really the goal here, to get comfortable with using that format. So I'm going to look back into my notes and write out the format that we're going to use. Now, each time we do dimensional analysis, we're always going to put our work into this format. We're going to have a measured number here times a conversion factor, and then that's going to equal our answer. So a good place to start is by thinking through what unit you want your answer to be in. And we see here that our purpose is to find how many jelly beans are in the jar. This is really what I'm looking for. How many jelly beans? Now this unit's a little tricky because it's not a typical unit like grams or milliliters or centimeters. If I ask you how many jelly beans, you might say 17 jelly beans. And that is the unit of our answer. The unit of our answer is just going to be in beans. Now, in dimensional analysis, remember that we're trying to get rid of all of our units except the one we want to end in, which for us is beans. And so this unit automatically goes on the top of our conversion factor. And the trick is we want to figure out what the other units are going to be in. So we want to look and see what kind of measured information we have about jelly beans. And you can see up here that we have some measured information up here. We have the mass of the jar when it's empty and the mass of the jar when it's full of jelly beans. So pause the video here and see if you can come up with a number that is measured about just the jelly beans. Hit pause. Now, what you hopefully came up with is if we subtract these two numbers, we'll get the mass of just the jelly beans. Okay, so I'm going to take 1,324.7 grams, which is the mass of the jar filled with jelly beans, and then subtract 392.5 grams, which is the mass of the jar empty. And when I do that, I get 932.2 grams. This is our measured number, 932.2 grams. We'll talk about a tip for figuring out what your measured number is when we're done with this problem. So if we return to our dimensional analysis, we're still missing a unit down here on the bottom. And remember, we want to get rid of grams and introduce beans. So if I have grams on the top, what do I need on the bottom? That's correct. It's grams. You have grams on the top, grams on the bottom, like that, and they'll reduce out and be equal to 1, and that's how we get rid of grams. So what we're left with here is our conversion factor. It's a fraction. It has 2 units, and the top has to be equal to the bottom. So what we need to find here, this is what we're going to need to measure. If we have a certain number of beans in our hand, we want to figure out what the mass of that same amount of beans is. So maybe I go measure 5 beans and I figure out that the mass of those 5 beans is a specific number. That number is what I'm going to put right here. You could do the same thing with 10 beans or 1 bean. So go ahead and take your measurement and put your measurement in there. Click pause now. Okay, so when I did it, I got 545 grams was equal to 5 jelly beans. If I have 5 jelly beans in my hand, what I'm holding is 5.45 grams in my hand. So I'm going to go ahead and do this math now. 932.2 times 5, hit enter, divided by 5.45. Okay, so pause here and do that math and get me an answer. Click pause now. So what I got was 855 beans. I'm going to go back and check my work. I have grams on the top, grams on the bottom. So grams reduce out. The only unit I'm left with is beans. And the starting amount and the ending amount should be similar. If I'm holding 932.2 grams in my hand, I'm probably holding around 855 beans in my hand. I haven't changed the amount of jelly beans in the jar. I've just converted out of one unit, grams, and into another unit, beans. Okay, as promised, we'll talk about a tip for figuring out which of your numbers is going to be measured and which of your numbers is going to be your conversion factor. So if I set up 4 jars filled with jelly beans, which of those numbers would change? Would each of the jars have a different starting mass? Or would each of the jars have a different mass per 5 jelly beans? And the answer there is each of the jars would probably have a different starting mass. That's how you know it's your measured number. It's true for this jar only. The measured number is true for this jar only. That relationship between the number of beans and the mass of that number of beans is always going to be true for every single jar. So the one that's consistent is your conversion factor. The one that changes depending on your jar is the measured number.